How's that? There's always something, isn't it, to start a stream. Anyway. So, how SMARS fans, how you doing? Hope you've had a good Sunday, good weekend. So, are you wanting to build your own robot? Don't know where to start, what you'll need, or how to do it? Then you're in the right place. So I'm Kevin, I'm your host. I run smarsfan.com, and this is all about SMARS robots. So let me just bring up my notes and we can talk about what this session is about today. So yeah, in this session we'll be designing a Raspberry Pi camera holder for the SMARS Quad robot. So let me just show you here. I've got a SMARS Quad robot just here. Let's move that out of the way there. And on the front there you can see this little camera holder. And the one that actually comes with the files for the SMARS Quad looks very similar. This is the module here, if I can sort of zoom in on that. So it comes in two parts. There's a sort of a back piece and then there is a front piece. And if we get our Raspberry Pi camera, there's the Raspberry Pi camera module. It hasn't got the ribbon installed yet. And we try and put this in there. Although it looks like it might actually fit in there, there is a very large hole at the front, and there's no way for this to actually go inside the actual holder. If I can show you that, it doesn't quite fit. So you try and squeeze it in there. There's nowhere for the ribbon to come out. It doesn't really work. And on the version that I'd printed out, I think it was actually the PLA that was the issue here, but this actually snapped off. So I thought we can do better than that. And I thought this is quite an interesting exercise to do. You know, how do we solve a problem like this? We want to design our own camera module holder. We've got the tools such as Fusion 360. So how do we do this? So that's what today's episode is all about. We're going to use Fusion 360. I'm going to build a new camera module from scratch. So let me bring up my notes. I've got my notes on one screen there. I know we're going to be doing this on the other screen there as well. So let me bring up my keynote. So if I just do that. So here we go. So what do we need? We need a Raspberry Pi camera module and we need Fusion 360. So that's the Raspberry Pi camera module that I've got. And what do we need this to do? Well, we need a hole for the actual lens itself. We need a ribbon hole, so when the ribbon goes into it, we've got somewhere that's come out. And what would be really cool for sort of bonus points if we have time is rather than having this round connector on the back, which connects to this sort of array of, see, I've got a piece of blue tack there just holding that in place. At the moment this just kind of wibbles about there, so I just put a piece of blue tack in there to sort of hold it into place a bit. But what would be really cool is if we could have a servo that can actually position the camera up or down, a bit like we have on the I just pull one of these up here, a bit like one of these module holders. So there's essentially two parts there. If we just move this away, this is the forklift thing. So there's a servo holder in there. You can just see the servo horn there, and then this slides into the top of the SMARS. So it'd be cool if we could have something like that for kind of bonus points. Might not have time to do that today, but that's certainly where I'm thinking we should go with this. Okay, let's get back to our keynote and back to there. So that's what our requirements are for this solution. And the dimensions. So this is all about measuring things and being quite accurate with this. So I have a pair of digital calipers, and these things are actually on all the time. I don't know if this is just a cheap digital caliper. However, it appears to be switched off. As soon as you sort of move this in any way, if you just sort of open this up, you'll see it sort of springs into life there. And there's a tiny little watch battery in there. And because this is essentially always on, these things don't last very long, the batteries. So I've seen people sort of hack them together where they've got a battery stuck on the top or duct tape to it or whatever. Just something that irritates me. That anyway, so we have our calipers, and one of the things we'll be doing is measuring exactly what the dimensions of this are. So for example, on there you can see that's roughly 24.8 by about 24. It says 23.93, so it's about 24.8, 25 by 24, something like that. So we have some measurements that we can start taking now. We have to measure things as well, like the the height of this thing. So what's the total height, including including the little ribbon connector there. So if I sort of show you that there, just in a little window, you can kind of see what we're getting out there, and that's saying about 9.4, something like that. So I've written all these measurements down, and what I've actually done is model this in Fusion 360 as a component that we can pull in, because then it's much easier to sort of build around that, because essentially we want to get this and then we want to encase it in some kind of module that's got the right connectors and the right holes on, and then slice it down the middle. So it gets quite an interesting problem to solve this. So that's our starting point. So as you can see, or maybe you can't see there, but I'm going to help you with that in a moment. I've modeled this, and in Fusion 360, once you've designed something, you can actually create a sheet from that, a drawing that has all the measurements on with all the different views. So you can have a top view, a side view, front, back, all the different orientations. You can even do sort of a section analysis where you slice through the middle of it if that's something that's important. But what this means is that you can pass this to somebody else and they can recreate this very easily. So I'm quite a big fan of these, and it takes me back to my days of high school when we used to do, what do we call it, graphic design, or I'm sure, I don't know, technical drawing, that's what we called it. And we had, pencils, and we had the big, the big sort of boards where you'd get the paper on there, you clip it on, and you'd sort of have to draw out things. And we drew things like the Volkswagen logo. I remember that being one of the things that we had to learn how to draw. And this is kind of the thing that we had as a sketch to draw from. So that's our starting point. So I've created that as a drawing, and you can get a copy of that if you want as well. So I've created that as a PDF. What we want to actually end up with is kind of a module that has the Raspberry Pi in the middle, and it's going to be encased by a top half and a bottom half. And the idea being that these top half and these bottom halves are sort of perfectly designed so that they have all the supports and everything needed. So that thing is snug and it's enclosed properly. So that's what we want to do, and we also want it to look like the SMARS kind of design language as well. So we'll talk about that when we get to it, what we mean by that. So like I said, there's a top half and a bottom half. There's a hole for the camera lens that's kind of the right kind of size for the camera, rather than having the great big hole that this one has. It's push fit connection, so when we print it, we don't really need to do anything else other than just push these together, and there'll be friction fit. And we have a hole as well, you can probably just about see it there, for the ribbon cable to come through. And you can see on the bottom half there, there's a sort of cutout for that too. So I've actually printed one of these. That's what I actually have installed on this this guy here, and I have another one, a slightly different prototype that I'm currently working on too, which is just here. It's got a Raspberry Pi 4 just sort of dangling on the top there. It might be a 3. But yeah, it's got the same kind of module there on the front too. So let me just go back to my slides. So if you want to get a copy of the module design cheat sheet, all the different measurements and everything, you can get a copy of it for free. All you need to do is go to action.smarsfan.com/camera, just put in your email address, and you can download that straight away. So let's move on to the next bit. So if you're liking this video series, or any of the videos that I put out there, and I've put out about 34, 35 now. If you enjoy these, please do, like and subscribe. Liking the video tells me that you like that specific video and that you got value from it. Subscribing helps me, communicate to you that there is more videos out there, and the more subscribers we have, the algorithm will pick up on that and share it wider. And we want as many people as possible to be building these SMARS robots, because they are just so good for getting people started in robotics. And you don't have to just start there and then leave them. You can build them out, as we did in this series, where we looked at face recognition, we looked at speech and voice synthesis, some really cool things, and I think in future videos we'll really build them out as well. So yeah, if you like and subscribe, and then press the little bell thing, you'll know exactly when I go live as well, because sometimes I go live throughout the week, and also I release videos which are related to robotics, such as the InMove head, which I have over here. So InMove is the robot that looks kind of like a person. We've got issues with that camera again. That's my overhead camera, but it just seems to be locking up. Anyway, so that's what we need to do for like, comment and subscribe. and it's demo time. And then I've got a note to myself there to play some cool music in the background as well, because we're going to be doing quite a lot of stuff with me talking and clicking, so it'd be quite nice to have something in the background. So I've got a bit of a playlist here that we can play too. What I'll do, I'll just need to turn down the volume a bit because it'll be quite loud, I think, when it comes through. So let me just play that. So if I put that right down to about there, how's that? That's not too irritating. Right, okay. So what we need to do now is go over, to Fusion. And well, let's get to it. So I've got Fusion 360 loaded up here. This is free software if you're a hobbyist, if you're a student in education. You might have to find your way through the Autodesk licensing system to get the license for this, but I found it quite straightforward to do, and they're always updating the software, and this is the best software on the market for doing 3D design, especially if you want to take that and put it onto a 3D printer and print out a model. I find this is just the best software, bar none, and I have had to play with a few of them to make that assessment. So this is what we're using. I've got two setups here. I've got one view there, and I've got a slightly more zoomed in version as well that I can click. So if we're looking at something and it's not quite visible on the screen, we can zoom in on that. Okay, so the first thing we're going to need to do is create a new sketch. So, well, actually, before we do that, I'm going to bring in the camera module design, which I've previously designed. So if I just click on there, it's going to complain that I've not saved the file. So actually, the very first thing we need to do is give this a name. So we're going to call this Raspberry Pi camera module holder, really long name. There we go. And now we can actually insert into the current design this Raspberry Pi camera. So we're not going to be designing the camera module itself. That was just something I did beforehand. So that's fine. We can leave that there. And now we can create a new design. So let's do that. Let's do it on this plane here. And we can actually hide that Raspberry Pi module when we don't need it. And we can just bring it back just by pressing this little eyeball here. So the first thing we need to do is we want to capture the outside dimensions of this module and then build out from there. So what I'm going to do is I'm going to click on that. I'm going to press P to project, and then I'm going to click on the edges that I'm after, which is just kind of this edge, and this edge. So what that now means, if I just hide that again, we can see we've got some, maybe I didn't quite click that one there, do that as well. If I hide that, we can now see that we've got the outline dimensions of that brought into our sketch. And what we need to do is just draw a rectangle, which is exactly those dimensions. If I just do that, there we go, oops. Okay, so we now have that captured in our sketch, and what we want to do is build an outline around that. So there is actually a command for doing offset, it's called, and offset will offset from a particular area. So if we do -3, that'll actually offset around the outside of the camera. So this is going to be like the thickness of our case around it. So let's click OK on that. So that's our first sketch done. That's nice and simple. What we're now going to do is extrude that out. We're going to pull that out. So if we just go to our 3D view of this, what we want to do is pull this out. So I'm just clicking into that area there. I'm going to press Q to push pull, and you can see there we can pull and push the that shape that we've designed. So we actually want to pull it out about 5mm. So I'm just going to type 5 there, press OK. So we've now got kind of a square hoop kind of shape. And if we bring back our Raspberry Pi, we can see that perfectly encloses that. Okay, so next what we need to do is draw a sketch on the top of this surface here. So I'm going to click that, go to create new sketch, and let's just bring that down. Why is that? There we go. Okay, so what we need to do now is bring back the Raspberry Pi camera, and I want to draw a circle exactly where the lens center is. So if I zoom in on this, let's just zoom in on that. So exactly where the middle of this is, that's kind of what I want to do. So if I do P for project again, I can actually find that circle there. I'm just going to bring that in, that's all I need. Because that's where the light goes into the camera, everything else is just for show, but we might actually make a similar kind of one that goes out around the outside of that as well, because it just looks nice. So what I'll do that, I might pull that one in as well, so P for project, just bring that in too, and then I'm going to do an offset around the outside there as well, and that offset is going to be 1mm around the outside, so that's fine, and that will be the gap. Everything within here, if I just sort of show, I mean, all of that area there will be the hole. Okay, so that's the next bit we need to do. So what we now need to do is go back to, we can finish that sketch actually. We can now bring everything we want to pull up, but not the hole in the middle. So just this outside area here and here. Press Q to push pull, and we're going to pull that up just 1mm, like so. So now you can see how this is sort of coming together. Okay, so what we now want to do is go to the bottom half of this face here, and we want to do a push-pull down on there as well. So if I do Q, I can actually pull that down by 4mm. And if we look on the side there, we've kind of completely encased that Raspberry Pi within the case. Okay, so what we want to do now is fillet the edges. Let me just make sure I've done that correct. No, I've not. There's one more thing I need to do on the other side, on the bottom. So let's just go back onto the bottom there. I'm going to select this face. I'm going to create a new sketch on there. Just move that to there. And I'm just going to do a rectangle from that corner to that corner there. Make sure that is... It's not quite getting it to the edge there. There we go. Perfect. So I now just want to grab that and that, pull that down by 1mm. Okay. So now we've completely encased our camera. Camera's inside, there's a hole for it to come out, there's no ribbon hole yet, and it's looking quite blocky. So the next thing we're going to do, we're going to fillet these edges. So if I just grab this edge here, press F to fillet, and I push that in by 4mm, and then I just select these by, I'm holding down the command key on the Mac, and that one there. We've now filleted those 4 corners. Now the reason I picked 4mm is the original SMARS, if I just find one, I just pull this up here for a second. The roundness that's on these edges here and underneath here, this is part of what gives the SMARS its kind of unique look, and we call this the design language. So this design language that we use for the Mac, Mac, I've got the Mac in the corner and I'll tell you about that in a second as well. The design language for this, we want to make sure that everything that we design as a module add-on has the same kind of design language, because then it looks like it's a perfect fit and that it was always part of the original design. So it's just a little tip that we need to think about when we're putting this together. And the reason I was thinking Mac there, as well as having a little Mac behind me on camera there, that Mac Classic, when they designed that, the design language was called Snow White, and they kept that for quite a while. So all the printers that they brought out, all the mice, I think there's like a modem as well, lots of different add-ons and extras, they all had the same kind of curvature, the same kind of look, the bezels were all the same. So that's what I mean by design language. They changed that after a while because it did look dated quite quickly. Okay, so we've filleted the edges there. Let's go to the full screen there so we can see what we're doing. That's better. And what we want to do next is do a few more fillets. So let me just OK that. So this edge here, I'm going to fillet this edge, and I'm going to do that by 2. Is it 2? No, it's 4. Sorry, 4mm. It's the bottom edge that's 2. So I'm going to fillet that bottom edge. F for fillet, 2mm, and there we go. This is looking a lot more like what we want it to. Okay, now what we want to do now is we want to split this into 2 halves, and the easiest way to do this is by creating a plane. So what we're going to do, we're going to select this top area here. We're going to go to construct, and we're going to do an offset plane. And I know that it happens to be -9mm. That's where I want my cut to be. Now that hasn't done anything, it's just put a plane on the design, and we're going to use that to create a split. So we want to modify, and we want to split the body. So here, the body to split is this body here. There's only one body at the moment, which is body 1, and the splitting tool is going to be that plane. So under construction we have plane 1. So that's what's going to happen. It's going to use that to slice through and create 2 bodies. So if you look over here, we've got body 1. When I click OK, we've got body 1 and body 2. And if I turn them on and off, you can see there that we literally have a top half and a bottom half. So I'm going to click on here. I'm going to rename this to be back, and then this one to be front. Oops. So let's have a look. Let's just put that as front. Hey Dr. Elo, how you doing? Thanks for joining the stream. Yes, it's really flying along this new Apple MacBook M1. No problems at all with this. Right, so that's the front and back section done. And that was very easy for us to split. Now the problem with that now is that these have no kind of purchase on each other. They would literally slip and slide around. So we need to design something that's going to latch these things together. So what we need to do is design exactly that. So I looked at the original design that Kevin Thomas had done, and what he's actually created there, if we can sort of zoom in on this a bit, you can see there's kind of an inset area. It's quite hard to see because it's white and it's quite bright there. There we go. So there's kind of like a square rectangle all the way inside, and with this one there is also a sort of a wall that's in there around the outside, and these things when pushed together create a push fit connection. So it's quite strong, very simple for us to do. So that's what we need to do. We need to design that little insert rectangle, extrude it out. So that's what we're going to do next. So let's just go back to the full screen there. So let me pull. So what we need to do is we need the back piece, and we need to turn off the Raspberry Pi camera. Have I named them incorrectly? I think I have. I think that's actually the back piece. I think that's actually the front piece. Well done if you were following along and you spotted that. Right, so we've got the back piece, and that's the piece that we want to look at. So let's get this up like so. So Dr. Elo's asking, is this for 3D printing? Yes, so ultimately we're going to 3D print this part out for our robot, which looks like so. And this part here is what we're actually going to create. It's a little camera holder, and the camera is a tiny little component like this, and we want to have this sit on the robot. So there's our robot. It's got kind of a pivoted area there as well that we need to create. And the one that comes with that design isn't really suitable. The camera module holder that was created with that wasn't designed for a Raspberry Pi. So we're just going to recreate that in Fusion 360. Okay, so there we go. We've got our holder there. What we need to do, let's just get this so we can look at it properly, and we want to create a sketch on there. Right, there we go. And what we want to do is do a rectangle. So we're going to do, let's just make sure I've got all my settings correct on here. So we've got snap to grid. I don't think we want snap to grid on, actually. I think that was getting in the way. There we go. So we can just draw a rectangle like that and then use this constraint, this coincident constraint. So if we click on that and we click on that point there, and then we click on that and click on that point there, that's now locked into place. And if we ever change the design underneath that, because those constraints aren't specific, just looking at my little camera there, seems to have paused. What's going on there?